Hi everyone, welcome back to my channel Vortex MrRoy. Exercise 9.1 question number 13. This is about the range of the quadratic equation. This equation is very important, like once again, like how we find the quadratic equation range. Let's start. First of all, we have this function is a quadratic function. When I write this quadratic function, we can also write like this: 2x minus 1 whole square and plus 1. And when we compare with this ax minus h whole square and plus k, where h and k are the turning point. So what is the turning point here? The turning point is 1 and 1 because normally we change the sign. H is positive here. Okay. The turning point is clear, and the first part is to find the range. So the domain is like 0 is there. I am writing 0 minus 1 whole square and plus 1. And when the domain is 0, this is 0 minus 1 is minus 1 square is positive 1, 2 is coming 3. And when we substitute here like 3, so is coming 2, 3 minus 1 whole square and plus 1. And this is coming 2 and 2 square and plus 1 is coming 2 to the 4, 2 to the 8 and is coming 9. Okay, when the domain is 9, the image is like domain is 3, image is 9. Okay, when you want to write like the range of this question, I told in my previous video, like the last video of this exercise 9.1, when the x coordinate of the turning point, like what is the x coordinate of the turning point? The x coordinate of the turning point is x is 1. This one, does it lie in the given domain? In the given domain, the given domain is 0 to 3. Check it out. This one, does it lie in the given domain? Yes, it's lie. When this turning point is lying in the given domain, so I will use this value of y, like turning point y is equals to 1. So it means the turning point, I will use the coordinate. And the second coordinate is here is 0, comma 3 because domain is 0 and the image is 3. 0, comma 3. And here like domain is 3 and image is 9. Because we have decided that the domain, the x coordinate of the turning point is coming in the given domain, so we have to use the turning point. So this value is here, like here is y is 1, here y is 3, here y is 9. Now to find the range of this question, you have to just write one thing, like f of x here, and we have like equals to, greater than equals to, less than equals to. Here I will write the minimum value from these three. 1, 3 and 9. So minimum value is 1 and the maximum value is 9, and this is called the range of this question. And if you want to know the answer, I think so the answer is here 9.1 question number 13, 1 to 9. It's absolutely right. Moving to part B. In part B, okay, if you want to like if you want to understand like by using a sketch, I would like to just give a little idea about the turning point, this range, and I write all the coordinates, like three coordinates. This 1, 1, maximum is 9, so I will write 9 here first of all, and 3 will be definitely here because we do not need to write all the sketch, and 1 is definitely here. We need 1, 3 and 9. Okay, the 1, 1 and maximum. Okay, what can I do? This is 1, this is 2 and this is 3 is enough. First coordinate is 1, 1. This is a turning point, and I told in my like video in chapter number 4, whenever you mark the turning point, we always draw an imaginary line, this line of symmetry. Okay, line of symmetry is here. Then I need 0, 3, like 0, 3 is here. And then we need 3 and 9. So 3 and 9 is here. When you draw the sketch of this function, quadratic curve, okay, it's not good, should be, okay, this is here. When you see the image, like the sketch of this given question with a given domain 0 to like 3. Now, just observe one thing here. What is the minimum value of this curve? The minimum value of this curve is 1 and the maximum value is 9. That's why the sketch is having the image like range 1 till 9, and we have done. This is the way actually. So moving to like B part, in B part, I think so there is no problem. In B part, what you can do, in B part, just 3 you can write in the equation 3 is equals to 2x minus 1 whole square and plus 1. This one will move in left hand side. 3 minus 1 is 2, and this 2 divide is upon 2 is coming x minus 1 whole square, and so it's coming 1. And when you write like under root of this 1 is coming x minus 1. Under root 1 means you will write plus minus 1. So x minus 1 is equals to 1 and x minus 1 is equals to minus 1. So x is coming about 1 minus 2 and this is coming 0. So I have two values. When we substitute the second, like 5, so 5 is equals to, in the given equation, to x minus 1 whole square and plus 1. And I'm solving like here. So 5 minus 1 is coming 4, and 4, and this x2 will divide, is equals to x minus 1 whole square, and is coming, if I'm not wrong, yes, it's right. It's coming 2 is equals to x minus 1 whole square. When you write x minus 1 like under root 2, so that will become plus minus under root 2. You can give the answer in decimal. So 1 time is plus under root 2 plus 1, and 1 time is x is equals to minus under root 2 plus 1. So now we have two values. Now to find the domain of this question, what we have to do for the domain, one thing, this was plus 1, this was minus 1. So this was like plus and this was with minus. So this plus and this plus will give one domain. This minus will give other domains. In this plus, the result is 2, and this plus result is like under root 2 is 1.4. This is more bigger. I will write 2 and x and this whole value. You can write 1 plus under root 2 or is up to you. There is no problem. Second domain, you can write like from the minus and minus. This is 0 and this effect is 1. Root is 1.4. When you minus is coming negative, and negative is lesser than 0. So I will write this first. So you can write also 1 minus under root 2 or minus under root 2 plus 1 is okay. And the domain is this one. So by this way we have done question number 13 with a sketch how to find the range and the domain of the quadratic function. The other parts of these questions are like simple. This was the 13 was about the range. In question number 14, when you see the function f of x is 1 upon x plus 1. This part is very important. X is not equals to minus 1 means this cannot be 0. That's fine. Because when you write minus 1 here, minus 1 and plus 1 is becoming 0. So 1 upon 0 is not possible. And same thing, the g of x is x upon x minus 2. Here, we cannot write 2 here. That's why it's given x is not equal to 2. Okay, find the values of this. So fx is equals to 10gx. Like what we have to do, we have to write the equation. We have to substitute fx is 1 upon x plus 1 10 times x upon x minus 2. Now you have to simplify, like you can do the cross multiplication. So the 10x multiplied by x plus 1, and here x minus 1, 2 will multiply with 1. So this is 10x square plus 10x minus x and plus 2. Now we need to do the solution actually. So 10x square plus 8x plus 2 is equal to 0. The mistakes are possible. So the common is 2, so I can divide the whole equation by 2. The easiest method, this will become 5x squared, and this will become 4x, and this will become 1 equals to 0. Now you need to make the factors, and to multiply to get 5 plus to get 4, I think so the easiest factors are 5 and plus to get is not possible. So we need to use a quadratic equation. A is equals to 5, B equals to 4, C equals to 1. Let me check. Multiply to get 5 and plus to get 4. I think so. Not possible. No, it's not possible. X equals to minus b plus minus under root b square minus 4ac divided by 2a, and we need to substitute in the quadratic formula. So is minus 4 plus minus under root b is 4 squared minus 4, a is 5, c is 1, and divided by 2a is 5. So by this way you can get the like two answers plus minus. I think so the answer will be coming in decimal. Let me check. Question number is like it's coming 1 upon 2 and 2 upon 5. So I am also thinking about just making the factors plus to get 4 is not possible. I think so. 2, no, it's not possible. Okay. Let's see. I'm solving this minus 4 plus minus. This is coming 4 is 16 and this is 20. When the roots are possible, the factors are also possible. But let's see. This is minus 4 plus minus. Okay, 16 minus 20. No, no, something wrong. Something wrong, something. Oh, it means we have done a mistake. This is possible because negative cannot be 0. So it means we have to be careful. 10x and minus x plus 2. Oh, this was a mistake. So possibilities are there. I'm sorry. So now if we write 9, then I think so there is, we cannot divide with this, and 10 times 2 is 20, multiply to get 20 and plus to get 9. This is the factors 9x squared plus we can write 5x plus 4x and plus 2. So the factors, like you can take common, 5 is common, x is common, 2x plus 1 and plus not 4 is common, 2x, sorry, 2 is common, so 2x plus 1, we have the same brackets, so 2x plus 1 and 5x plus 2 equals to 0. We don't need this because this is very good that I want to show you. In bracket, in under root, it cannot be like negative value, like negative 4. It is not possible. This is not in our syllabus in additional maths. When you move to A levels maths, then it's possible to have negative under root. This is called the iota. Like this is not like you don't need to use it now. So now moving to this part here, what we have to do, 2x plus 1 equals to 0 and 5x plus 2 equals to 0. So x is coming minus 1 upon 2 and x is coming minus 2 upon 5, and I think so answer is minus 1 upon 2 minus 2 upon 5 to side. So I don't want to edit my video actually. So that's a mistake and we got it. This where was our mistake and we found right answer. So next question is 15. In question number 15, f of x is 3 upon ax minus b, and gx is bx plus a. So first condition is f of 1 and g of 1 both are equal. So we can write f of 1 is 3 upon 1 is here, a times 1 minus b, and g of 1 will be, now this 3 upon a times 1 is a minus b is equal to the first condition we are applying here, and this is b plus a. And when you do the multiply, this 3 is equals to, we can write a plus b. This is a minus b. So we can write a squared minus b squared equals to 3. This is the first equation we got. Okay, second condition is here. Uh, please, this is f of 2 times g of 2, because this is not a complex. This is not 9.2. In 9.2, we have this different case to write, different way to write. So just normally you have to write f of 2. I will put here 3 times 3 upon a 2 minus b times g is here bx. So b, I will write b times 2 plus a. So this is in the bracket equals to 4, and you can just multiply 3 times b and 2 is 6b plus 3a equals to, this will multiply in right hand side, so 2a will become 8a minus 4b. Now we can simplify now. This is coming 8a and 3a, and this we can write here 6b minus is plus 4b. This is 10b is equals to 5a. So a is coming 2b when you divide. So okay, the value of a is coming 2b. We can put this value here in the first equation. So a is 2b squared minus b squared is equals to 3. 4b squared minus b squared is equal to 3. 3b squared is equal to 3, and b squared is equals to 1, and b is equals to plus minus 1. And remember, in this question is already given the a and b are positive constants. So positive means I will write only b is equals to 1, and this value I will substitute here, and that will become 2 times 1 is equals to a, and a is coming 2, and that's, we have done question number 5. Question number 16, I will not solve in detail, but I can just give the idea, this how we can simplify or how can we solve this question. Find in terms of a, the expression of all these. So what we can do, the first part, g a plus 1, I just need to write in the place of x a plus 1 and minus 1, and you need to simplify 3a plus 3 minus 1 is coming 3a plus 2, and this we have done. So by this way you have to do all the parts, I think so. There is no problem. So this question number 17, let's see, the f of x is ax plus 1, and the g of x is 4b and x minus 1. X cannot be 1 is given here, and this we don't need this. But the first condition is f of a is equals to g of b. So f of a means I will write a here in the place of x, and this will become a squared plus 1. This is f of a. I need g of a now. G of a will be, sorry, g of b. So g of b will be 4b upon, I will just put the value in place of x only, just here. So we have two this equation and this equation we can equate like a squared plus 1, this one, is equals to 4b upon b minus 1. By this way, when we arrange this, this is coming a square with b is a squared b, a square with 1 is minus a squared, but this is plus b, and this is minus 1 is equals to 4b. When you want to arrange, you can arrange, but when you move to second part, this part, so it means I have to put f 1 upon a. So 1 upon a means this equation will become a times 1 upon a plus 1, and that's the value. A cancel out, is coming 1 and 1 is coming 2 only. So next you have to put 1 upon b in g. So this will become 4b divided by 1 upon b minus 1. And if you want to simplify like some part of this, so you can write 1 here. LCM is b, and this will 1 minus b. When you will move up, multiply with this 4b, this will become reciprocal, like 1b upon 1 minus b. Or even you can write one thing, divided by the same 1 minus b upon b. Then you can write multiply b upon 1 minus b, and this is 4b squared divided by 1b. This is g of 1 upon b. Now you can equate this equation and this equation by using this condition, and we can have the value of b, and then value of b will be substituted here in this equation, and you can get the value of a. So I don't want to solve this because the videos become very lengthy. This like I would like to say once again, this question number 13 to find the range in the quadratic equation is very important, most important. And the next topic is about the composite function 9.2. I'll be moving soon. And thanks once again, that's all of you who comment in my video and like my video and ask to make some videos. I'm always ready, but I'm also very busy here. So whenever I'll get the time, I'll make the videos. And once again, I would like to thank you so much, and please share this video with your friends and his class fellow. Thank you so much and have a nice day.